We spend pretty much our entire lives online, but that whole world, it's really run by this secret language of blinking lights and humming boxes. So today, we're going to pull back the curtain and actually figure out what this essential hardware is that powers our digital world.
Right? Have you ever walked into an office or a server room and you see those racks of equipment and just think, what is actually happening in there? Well, you are about to find out. We're going to decode the function of each and every critical piece of networking gear.
And to really get it, we're not just going to list things, we're going to build a network right here from the ground up. First, we'll solve the problem of getting a few computers to talk to each other. Then, we'll connect them to the wider world. And, of course, once we do that, we have to tackle the big challenges. How do we keep it safe, and how do we keep it fast? Okay, so first things first. Our first challenge is pretty simple, really. We've got a few computers sitting in a room, and we need them to communicate. We need to create what's called a local area network, or a LAN. And to do that, we need our very first piece of hardware. This is a hub, and you can think of it as the most basic and, frankly, the loudest connector you can imagine. When one computer sends a message to the hub has no idea where it's supposed to go. So what does it do? It just shouts that information out to every single computer connected to it. It's super inefficient, it creates a ton of unnecessary noise on the network, and it means anyone can listen in on a conversation not meant for them. So, how do we fix all that chaotic shouting? Well, we evolve. We get a switch. A switch is so much smarter. See, it learns the unique address for each device connected to it. Think of it like a name tag. It's called a MAC address. So when a message comes in, the switch just looks at the tag and sends it only to the computer it's meant for. This turns that loud, messy room into a series of quiet, private conversations. Everything gets way faster and a whole lot more secure. All right, so our local computers can now talk to each other nice and efficiently. That's great. But what's the point of a network if you can't get out and see the world? Our next big challenge is connecting our private little LAN to the global internet. And this is the job for a router. A router is basically your network's traffic cop. It sits at the intersection between your private network and the giant public network of the internet. And its whole job is to make intelligent decisions about the best way for your data to travel to get anywhere in the world. And here's how it all fits together beautifully. The switch, that's the heart of your local network. It handles all the internal conversations. The router, well, that's your gateway to the outside world, connecting your entire local group to the internet. They've got totally different jobs, but they work together as a team to make it all happen. And, a router's job is a lot more complex than just connecting two networks. It's constantly making decisions. It filters traffic based on security rules, kind of like a bouncer with a guest list. And this is the really cool part. It uses something called a routing table, which is basically a dynamic map of the internet to find the absolute fastest and most efficient path for your data to get where it's going. So we're connected. This is awesome. But with that connection comes a huge risk. By opening a door to the internet, we've also created a potential entry point for, bad guys. And that brings us to our next critical problem, security. Our first line of defense is the firewall. A firewall is literally your network's digital security guard. It stands at the border between your private network and the public internet, and it inspects every single piece of data trying to get in or out. And if something doesn't follow the rules the administrator set, it gets blocked. Simple as that. And modern firewalls are incredibly powerful. They can scan for known viruses, they can filter content, like blocking social media sites on a company network, and they can even create these isolated safe zones for really sensitive systems, like a finance department's servers. But attackers are clever, right? Sometimes a threat might actually sneak past that front gate, so we need another layer of security, something that acts more like a surveillance system, constantly watching for suspicious activity inside our network. And this brings us to two systems that sound similar but are very different. First, you have an intrusion detection system, or IDS. Think of it as a detective. It watches everything, and if it sees something fishy, it raises an alarm. But then you have an intrusion prevention system, or IPS. This is the bodyguard. It doesn't just raise the alarm, it jumps in and actively stops the threat right then and there. It'll shut down the connection, block the data, it takes action.
Okay, so our network is now connected and secure. But what happens when we get successful? It's a good problem to have, right? But if you're running a popular website, thousands of users might try to connect all at once, and that can totally overload your server and crash your entire site.
The solution to this is a load balancer. This is a really clever device that sits in front of a whole group of servers that all do the exact same job. So instead of sending all the traffic to just one server, it intelligently spreads out all the incoming requests across the entire group. This makes sure no single machine gets overwhelmed. The process is simple, but it's so powerful. A request comes in, and the load balancer acts like an air traffic controller. It checks which server is the least busy and sends the request there. This keeps everything running super fast for the user. But here's the real magic. If one of those servers suddenly fails, the load balancer sees it instantly and just stops sending traffic to it. The users, they never even know there was a problem. It's seamless. And finally, let's talk about the proxy server. A proxy basically acts as a middleman. It does two really useful things. On one hand, it can speed stuff up by saving or caching frequently accessed web pages locally. That way, you don't have to fetch them from the internet every single time. And on the other hand, it gives an administrator really fine-grained control to filter content and block access to certain websites. So there you have it. From the humble, noisy hub to the super smart load balancer, each one of these devices evolved to solve a very specific problem, which really makes you wonder, with the explosion of AI, the Internet of Things, and just global connectivity on a scale we've never even imagined, what new challenges are waiting just around the corner? And what new secret hardware is someone inventing right now to solve them?